scheduler. So the inference rule that the book really talks about the most is modus ponens. If we know, or if we're told that X implies Y and we are told X, then it follows from these two statements that Y is true. Okay? So if I know X and I know X implies Y, I know Y. I can write that the other way. It still implies, except the arrow is essentially going in the other way. I think of this as simply implication 2 using a different convention. You can verify this with truth tables. Here is the X column. Here is the X implies Y column. And you'll note that when X is true and X implies Y is true, Y is also going to be true. And so this is one of the most common and intuitive forms of inference. But there are others. Modus tollens is another inferential rule which is sound. That is, it comes to deductively correct conclusions. Later on, when we talk about machine learning, the week after the exam, we'll talk about induction. Induction are rules of inference which are not guaranteed of coming to deductively sound conclusions. But here's another example, modus tollens. If we are told X implies Y and we're told not Y, if I go back and I look at the truth table, if I know X implies Y and I'm told not Y, there is one case for that. X implies Y is true, not Y is true, or Y is false. X has necessarily got to be false. And so not X follows from this rule using modus tollens. So another common rule. We're going to talk in more depth about a inferential method called resolution in a little bit. And it's interesting and we'll talk about both modus ponens and modus tollens in terms of alternative representations. But we know that X implies Y is equivalent to not X or Y. And of course, we know not Y is, there it is. So this is an alternative way of writing the modus tollens rule. The book briefly talks about something we're going to elaborate at the end of on this lecture called resolution. And you'll notice that if we are told that not X or Y and not Y are both true, both of these are true statements. Not X or Y and not Y. That means that not X must be true. If this or this is true and we know that this is actually false, then that's got to be true. Okay? And that's the basis for what the book calls unit resolution, and we're going to generalize that a bit and talk about resolution more generally as an alternative inference rule. So here's a basic proof. We're given these axioms. There's a typo there. I will correct that in the slides before adding this. But here are the axioms, and we want to prove Q and S. We have two rules, two modus ponens steps for one tells us that Q follows from these axioms, and the other application of modus ponens tells us that S follows from these axioms. We know both of these. And believe it or not, in rigorous propositional calculus, propositional logic, we would then use an additional inference rule called AND introduction. We know this, AND introduction simply says, if you know A and you know B, you can AND them, and that's also true. That's a valid conclusion. And so we have a third step called another inference operator called AND introduction. I note that because modus ponens by itself is not sufficient for proving, even in propositional logic, it's not sufficient. Modus ponens all by itself is not sufficient for proving all that might be logically valid or follow from a given database, a knowledge base rather. We're going to go back to that observation a little bit later when we talk about resolution, but here is going through a couple of examples that the book goes in some detail. You can study this example. It's an illustration of how a system designer might go from a knowledge about a domain to a set of propositions for purposes of reasoning, in this case diagnostic reasoning. So these are atomic propositions. These are also atomic propositions. The book makes a distinction between that which you are, that which is a permanent part of the knowledge base, and that which a user, through interactions with the system, might report observations on the fly as one is interacting with the knowledge base. And the meeting after the exam, we're going to talk more about this, because interactivity, the book has a, one of my favorite parts of this chapter is the discussion of how humans might interact with a theorem-proving AI in propositional logic. And that interface, I think, is interesting and important. And it might be something that you